Let A be the set containing the elements 1 to 9, and R is a relation on the Cartesian product of the set A with itself, and it is defined by the ordered pair A comma B is related to the ordered pair C comma D if and only if A plus D equals to B plus C for all ordered pairs A comma B and C comma D belonging to the Cartesian product. If R is an equivalence relation, then we need to obtain the equivalence class of the ordered pair 2 comma 5. Okay, let us begin. So let's write down whatever we have been provided with. So here we have a set A. Set A contains the first 9 natural numbers. So we have 1, 2, 3 all the way up to 9. And then we have a relation R which is defined on the Cartesian product of A with itself. That means R is a subset of the Cartesian product of A with itself. And then R is also defined here. So R is defined as the set of the ordered pairs A comma B and ordered pairs C comma D, and these two ordered pairs is going to belong to the Cartesian product of A with itself such that they are related to each other as A plus D equals to B plus C, meaning here we are taking the sum of the outer elements of the two ordered pair A and D, and this is going to be equals to the sum of the inner elements B and C. Okay, fine. Now we have to find out, and it's also given that R is an equivalence relation. That means the relation R is symmetric, it is reflexive, and it is transitive in nature. Now we need to find out the equivalence class of the ordered pair 2 comma 5. Okay, now this is going to be a set. Clearly this is a set, and this set is going to contain an ordered pair x comma y, and its ordered pair is going to be picked up from the Cartesian product of the set A with itself such that the way we are picking up the ordered pair x comma y is such that it has to be related to 2 comma 5. This is the definition of the equivalence class. So let's take the help of the relation to rewrite this set. So that means we have a set of ordered pairs x comma y belonging to the Cartesian product of A with itself such that we have x comma y related to 2 comma 5. So what we'll do, we're going to take the sum of the outer elements, that's x plus 5, and this must be equals to the sum of the inner elements y plus 2. In other words, what we can do, we can rewrite the set as x comma y belonging to the Cartesian product of the set A with itself such that. So let's rearrange the terms, and this is going to give us y going to be equals to x plus 3. Fine. Now we have to pick up the values of x such that we get the corresponding y values, and we have to make sure that x and y, these are picked up from the set A only. So since A is the set of first 9 natural numbers, so let's begin by picking up x value to be equals to 1. So when we pick up x to be equals to 1, so 1 added to 3 is going to give us the corresponding y value, which is 4. Then we have x equals to 2. So x equals to 2 gives us y equals to 5. X equals to 3 gives us y equals to 6. X equals to 4 gives us y equals to 7. X equals to 5 gives us y equals to 8. And x equals to 6 gives us y equals to 9. And we have to stop here, because if we take x equals to 7, then y value is going to be 10, but 10 is not a member of the set A. So this is going to be the equivalence class of the ordered pair 2 comma 5.